This is the first section of chapter 3 on continuous distributions, and this section is on the continuous random variables. So far in Further Stats 1 and Statistics and Mechanics 1 and 2, you've been introduced to the following distributions. So binomial, Poisson, geometric, and negative binomial are all examples of discrete distributions. And the only continuous distribution that you've learnt about so far is the normal distribution. Now we can define another type of continuous distribution using something called a probability density function, or a PDF. Now a probability density function would look something like this. So the probability density function is defined as f of x, so you'll see f of x like this, equal to, and what we'll have is we'll have different rows of working. Now each row of working, first of all, tells you the probability on this side and the outcomes on this side. So here this basically means if I want to work out the probability of any number of value from 1 to 5, its probability I'd work out by doing 4x minus 3. And this means that the probability of anything else, so otherwise just means anything else other than what we've written above, so anything else, is 0. So in other words, the only probabilities that we're going to get are for values from 1 to 5. Any value outside of that range has a probability of 0. Now here's an example of what a probability density function might look like as a graph. So notice we can have negative values of x, but the graph won't go below the axis because this axis here represents the probability of that outcome happening. So the first thing that we can say about a probability density function is that f of x will always be above the axis. It will always be greater than or equal to 0 for all values of x. We'll just write that down. F of x, basically the probability, will always be positive. We'll always have a positive probability for all, and this upside down a like this just means for all real values of x. Also, if this is not a sort of nice thing to work out, so we haven't got like triangles or rectangles to work out, and we want to work out the probability of something happening. Let's say I want to work out this probability here between A and B. Well, I need to find the area of that, and we can use integration. Unless it's a nice easy function where we can just work out the area of triangles, rectangles, or trapeziums, we find the probability between A and B by integration. So we'll just write that down here. So the probability between A and B, like this, we get by doing integration, and we integrate the probability density function between A and B. Also, because this is a continuous distribution, the probability of a x being one particular value, so the probability that x equals one particular value, is 0. That's a bit like saying what's the area of this line, yeah, because we're just finding the probability of one thing. And the last thing is, we know that the sum of all probabilities is equal to 1. So the area under the function, which here it just stops between these two bits, but it could go on forever in both directions, like a normal distribution, the tail's going forever. So between infinity and negative infinity, the area under the curve or under the graph is equal to 1. That basically means that the sum of the probabilities is equal to 1. So these are the features that we'd have from a continuous distribution, and in particular we have this way of defining this continuous distribution, which we call a probability density function. example 1. In each case, state whether the function could be a probability density function where k is a positive constant. So there are a couple of ways we could do these. We could use integration to work out what the area is and make sure the area is equal to 1, or we can sketch them. So quite often we're asked to sketch the probability density function, so we're going to do that. So we just get the practice. So let me just do my axis here. So that's my f of x axis and my x axis here. And it's just between 0 and 3, so something like this. They're my x values, and between 0 and 3 the probability is 2x plus 1. So when x is 0, if I put 0 into here, I'm going to have 1 on this axis here, and then when x is 3, I'll have 2 times 3 plus 1, I'll have 7 on this axis here. So I can basically draw a line that looks like this. Okay, and for this to be a probability density function, this area should equal 1. So let's see if we can do that. It's a trapezium, so that should be easy enough to work out. So we'll take these as the two parallel sides. So we've got 1 and 7 as the limits of the two parallel sides. So 1.7 divided by 2 times by the height, which is 3. So I'm going to get 8 divided by 2 times by 3, 4 times 3, 12. So since the area does not equal 1, this f of x is not a probability density function. Now another way of doing it is we could say, right, let's work out what the area is between 0 and 3 for 2x plus 1. And so if we integrate that, 2x becomes 2x squared over 2, so it just becomes x squared, and 1 becomes x. So if we substitute the 3 in, we're going to get 3 squared plus 3, so 9 plus 3, 12, plus nothing. So again, we get a value of 12. Right, let's have a look at part B. We want to work out if this is a probability density function. So we're going to do the same thing again and sketch this. So I've got my axis drawn here. Notice that the x values can be negative, but f of x can't be negative. So let's see what happens. Right, so when I want to find out what it's going to be on this side, so we'll substitute x for -2. So you'll get k times by 2 minus -2, or 4, so you'll get 4k. So at this end of the graph over here, it's at 4k, so put a little dot there. And then at the other end, where x is 2, so it's going to be 2 minus 2, so 0k or 0. So at this end, it's going to be over here, so let's draw the line in. So it's going to look like this. Now we want the area of this to be 1, so with an appropriate value of k, we can make this area equal 1. So we can say this is a PDF for a particular value of k. So let's work that out. So the area of this, which is just a triangle, is going to be half the base, and the length of the base is 4, times the height, which is 4k. So that will give us 8k. So if 8k is equal to 1, that means the function is going to be a PDF, which means that k will need to equal an eighth. So when k is an eighth, then this is a PDF. And again, we could use integration to work out this area and say make that equal to 1, but it's straightforward. It's just a triangle. We don't need to use integration for that. So let's move on to part C, and we want to see whether this last one is a PDF. So here's my axis over here. Let's multiply out the brackets just to see what type of graph it's going to be. So that'd be 5kx minus kx squared. Okay, so this is going to be like a quadratic, and it's going to be an n-shaped quadratic. So it's already factorized, so I've got the roots of the quadratic as being 0 and 5. So my U-shaped quadratic is going to start by going like this. Okay, and that's going to be 5. But what happens after 5? Well, if we put 6 into this, and we'll get 5 minus 6, which is -1. We'll get negative kx. Sorry, we need to put the 6 on the outside as well. So let's work that out over here. So when x equals 6, we'll get 6k times by 5 minus 6. 5 minus 6 is -1, so we'll get -6k. So that means that this graph actually goes below the axis down here, and this bottom part here is going to be at -6k. Now we did say that f of x, PDF, can't be negative, can't have a negative probability. So this one is not a PDF. So we just write down f of x is not a PDF, since for, let's say, x greater than 5, f of x is less than 0. Example 2. The random variable x has probability density function f of x equals between 2 and 4 kx bracket 4 minus x and 0 for anything else. And in part A we want to find the value of k and sketch the PDF. Right, so we know that the area between 2 and 4 of this function has to equal 1. So we'll just write down that the area between 2 and 4 of kx 4 minus x dx equals 1. Right, so if we're going to integrate it, we'll expand the brackets. So we'll have 4kx minus kx squared is equal to 1. Now we'll integrate it. So 4kx integrated will become 4kx squared over 2. In other words, 2kx squared. So 2kx squared. And then the negative kx squared, when we integrate it, that will become negative kx cubed over 3, or minus a third k x cubed between 2 and 4. Now we could, if we wanted to have done, we could take out the k as a factor and write that over here and integrate it that way. That's a possibility. Either way, it will get the same answer. Right, so we know this is equal to 1. So let's substitute in the 4 and 1, make it equal to 1, so we can find k. So we'll have 2k times by 4 squared minus a third k times by 4 cubed minus 2k times by 2 squared minus a third k times by 2 cubed, and that equals 1. Okay, so let's work out what we get. So from the first bracket, we will get 32k minus 64 over 3k. Then the second bracket will give us 8k minus 8 over 3k. That equals 1. That actually leaves us then with 16 over 3k equals 1. That means that k equals 3 over 16. Okay, so we found the value of k. Next thing we want to do is now sketch this PDF. So here's my axis. Here I'm plotting it between 2 and 4. Now I can see that this is going to be a quadratic, and I'll end up with a negative x squared, so it's going to be a U-shaped quadratic. So basically what I want to do now is to substitute 2 into this and 4 into this to work out what the heights are at these 2 points. So when we put 2 into this, we get 3/4. So I'm going to put on this scale up here 3/4 or 0.75. So the graph starts off at that point. And then when I put 4 into this, then that's going to become 0. So the graph is going to go down to 0 down here. And it's a U shape. So it's going down like this. And I just need to show at this end that this is the end point of that PDF. Now you might be asking yourself, well, how do you know that that PDF doesn't go like this, that it doesn't go up and then back down? Well, if we increase the value of x that we put in here, so we start with x equals 2, if we increase this, that means this bracket's going to get smaller. It means the whole expression is going to get smaller. And I know this part is going to get bigger, but it's going to get scaled down the amount that it's going to get bigger by, because you're multiplying by 3/16. So this has more of an impact. This will make it more smaller than this part will. So it doesn't go up and then back down again. It just continues going down. And we'll move on to part B. And part B, what we need to do is to calculate the probability between these two values and give our answer to 3 decimal places. So that means integrating between the values of 2.5 and 3 are PDF, which is 3/16x, 4 minus x. Now we are going to bring the 3/16 over to the other side. It just makes it a little bit easier to deal with. So we'll have 3/16 integrating between 2.5 and 3. And then we'll expand the brackets as well. So that will give us 4x minus x squared, 4x minus x squared. Right, so we can integrate that. So we'll put the 3/16 outside the brackets here. 4 squared, when we integrate it, will become 4x squared over 2, or 2x squared. And then the minus x squared will become minus x cubed over 3, or you could put minus 1/3 x cubed. And our limits are 2.5 and 3. So the last thing we need to do is to substitute those two values in. So we're going to have 2 times 3 squared minus 1/3 times by 3 cubed minus 2 times 2.5 squared minus 1/3 times by 2.5 cubed. Now I almost forgot that I need to put the 3/16 factor here, so we'll just put that in. So 3/16, and then when we work that out, we'll get 41/128. But it does say to give our answer to 3 decimal places, so we'll use the SD button, and we'll get 0.32033125. So to 3DP, that'll be 0.320. So that'll be our answer for part B. Example 3. The random variable x has this probability density function. What we want to do in part A, first of all, is to sketch it. Okay, right, so part A. Right, so here's my axis. So what I've got between 1 and 2 is this function, just k. So it's going to be a horizontal line that has a height of k. So let's just label this 1, 2, 3, 4, and again up to 4. Whoops. And this line with a height of k between 1 and 2. So let's just do a line there. And this is going to be k. Then between 2 and 4, we have this line which is basically kx minus k. So that's going to be a line that's going up. So what I might do is just put this k a little bit lower, because I want that line that goes up. So let's put this here, k, and yeah, it's going to be a line that goes up. So I just need to know where the two ends of the lines are. So if I put 2 into this, I'll get 2 minus 1, so it's k at that end. And if I put 4 into this, that'll be 3k. So the other end of the line is going to be at 3k up here. So it's going to finish up there. So we'll just join that up like this. We need to show that that's where the probability ends. So we need dotted lines at either ends like this. Okay, so that's the sketch done. Part B, you want to find a value of k. Well, to find a value of k, this total area is equal to 1. So we'll split it up and we'll find the area of the rectangle and add the triangle and make it equal to 1. So the rectangle is 3 across and k up. So the rectangle is 3k, 3 times k. And add to it the area of the triangle here. And this triangle is a base of 2. So half the base times the height, and the height is 2k. So it's 3k minus k, so it's 2k high and 2 across. So let's just write that down, half times the base times the height. And that total area equals 1. So we have 3k plus 2k, basically 3k plus 2k equals 1. 5k equals 1, which means that k equals 1/5, not 15, but 1/5, like this. Okay, right. Moving on to part C, what we want to do is to find the probability that x is greater than 3. That's finding this area here that's greater than 3. So we want to find the area of that part. The probability that x is greater than 3 is equal to this area. Now, if we think of it as a trapezium, well, it's not really a trapezium because we don't know that length there. So we'll use integration. Yeah, we'll find the area between 3 and 4. That should be easy enough to do. So the area between 3 and 4 of the function kx minus 1. I suppose I could work out this value here and get like the length of that side. By the time I've done that, I might as well just do integration. So k is 1/5, so we'll stick the 1/5 over this side like this, and then we've got x minus 1 dx. So now we'll integrate x minus 1, which will be x squared over 2 minus x between the limits of 3 and 4. So we'll substitute those values in. So 1/5, 4 squared over 2 minus 4 minus 3 squared over 2 minus 3, and 1/5 of that. And that gives us exactly a half for the probability that x is greater than 3. Now, as I said, what we could have done is we could put 3 into this function, work out the length of this side, and then use the area of a trapezium, and we get the same answer. So you should now be in a place where you can do exercise 3A on pages 48 to 50 of the textbook, and it's just a quick recap of what we've gone through here.